some of the reactive forces, reactions because of the constraint given here, that's basically a rod with a cable. So that's the pull force of the rod. So that's a reaction of the cable. What I've got here is oh sorry, can I magnify it? Come on. Is it able to magnify? No. Okay. Excuse me. I'm looking at this one. I've got the rod with the link. That's the link. I do apologize, it's not very clear, and it's pivoted at both ends. So I can move the rod, I can rotate it. It's a link. So the only direction where I cannot move is in the direction of the link. So that would be the reactive force. This is the same example as the roller I've given here. It's not very clear here. So I'm talking about this one. Apologies, the picture is not that good. The roller, it can move in this direction. Because it's pivoted, it can rotate also. The only way it cannot move is moving inside. So therefore, I will have a reactive force. Now I'm looking at this one. It's a roller that moves in the channel, so it can move in this direction. The rod is pivoted, so the rod can rotate. The only direction where the rod cannot move is perpendicular to it. So therefore, I will have a reactive force perpendicular. Now I'm looking at this one. It's a rocker. You have to remember these things. It's a rocker. I can move along this direction. It works just like a roller. It's a rocker. I can lift it, but I cannot move it downward. So therefore, that would be the reactive force I will get. I'm looking at this one here now. And it's basically a rod on a smooth contacting surface. So it means it's a smooth polished surface. So I can move it in this direction. I can lift it. I can rotate it, but I cannot move it downward. I cannot do that because there's a ground. So therefore, I will have only one reactive force, and that's here. Now I'm looking at this one. So it's a rod pivoted on a slider. So it can rotate, it can slide in this direction, but it cannot move perpendicular to the slider. So therefore, I will have the reactive force given here. Similarly, I've got a pivot which is grounded, so I can rotate, but I cannot move the pivot up or left, right, or down. So I will have a reactive force. So this one, yeah, this is a slider. It can slide on the rod only in this direction. So it means I cannot rotate the top rod. I cannot do that, and I cannot move the rod in this direction. So therefore, you've got two reactive force. I've got this beam connected to the wall. I cannot move it in XY. I cannot rotate it. So therefore, you've got your three reactive forces. Is that clear to everyone?
सर लास्ट पेज में कुछ डायग्राम्स में पूरी एक्सिस पे वो ट्रांसलेट नहीं कर सकती थी, वहाँ पर आपने और के साथ फोर्स की दूसरी डायरेक्शन भी शो की है। सर जो 9th पार्ट है इसमें भी फोर्स की ऑपोजिट डायरेक्शन हो सकती है?
9th part. Okay, let me explain. I cannot move it in up or down. Okay, so I will have reactive force in this direction. So your F can be up or your F can be down, depending you're pushing it or pulling it. Clear?
Yes, sir.
Now let me go back to the other one. And I guess you're talking about
सर वो ऐसे ना जनरल पूछ रहा था मैं कि हमने पीछे पेज पे इस तरह किया है तो नेक्स्ट पेज पे इस तरह करेंगे, वो समझ आ गया। थैंक यू।
Okay. So now you got I don't know if it's clear. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 scenarios. So we've got this bridge with the cable hand pivoted. Which number it is similar to constraint wise? The cable can rotate, but the cable cannot move but it's a cable. Number
8.
It's a cable. Do you know the reactive force direction of a cable?
Sir, it's I guess pull from the.
It's always pull. So which one it should be?
Then the first one is the only one.
First one. It is the first one. Okay. And let's look at the next one. I don't know if you can see it. It's basically a pivot point, but it's fixed to the upper structure. What do you think? Which scenario? It's a rod which is pivoted, but the upper structure is fixed. So it can only rotate.
Second one.
Say again?
The second one.
The second one, let's look at the second. The second one is a link. There's no link here. It's a rod connected to a pivot.
So then it should be 8th one.
8th one.
Yes, it is the 8th one. Okay. Now tell me. It's basically, let me put it this way, it's a frictionless contact.
Sir, 4th.
It's a smooth contact. Say again?
4th.
Sixth one.
Which one would it be?
Sixth.
Number 6. Yes, it's a smooth contact. Okay. What we've got here is a rocker. You cannot see it, but the lower part is curved. It's like a rocker. So which one is it? Say again? It's number 5, the rocker, which means it can move in this direction. If you want to lift the bridge, you can, but if you want to move the bridge downward, you will not be able to do that. So the reaction force will be coming from the ground. But if you want to rotate, yes, you can rotate also.
Yeah.
Okay. I'm talking about this beam here, which is welded to the other beams.
Sir, 10th.
2.
It's rod welded. Think.
Sir, it should be the 10th one because there would
10th
be
one.
no degree of freedom.
Okay, so it is basically the 10th. It's welded. I cannot rotate the rod. I cannot move it XY.